So let's continue. About teaching and learning strategy. Our module delivery will involve lecture, research and practical experiments. The module will be future supported by tutorials. Relevant textbooks are essential if the student is to achieve the learning outcomes. Future details are given in the essential reading section. To achieve the learning outcomes, the student will need to complete group practical work with technical report of approximately 3,000 words, weighting 80%, and one closed book examination weighting 20%. Written examination equivalent with appropriate content such as calculations, images, tables, charts, and diagrams. Learning resource. First of all, this is a book, textbook, Material Science and Construction. Of course, you can use textbook Environmental Science in Buildings and books, materials from Alan Everett. But very useful are my lection. The selection will be the main resource to prepare your to exam. And now, introduction to module. This chapter provides an overview of mankind's use of materials, comparing the use of materials in various industrial sectors, and making clear the point that construction is the world's largest consumer of materials. It goes on to examine the importance of material properties in their selection for use and outlines the various types and classes of materials and their importance in construction. A discussion of the service behavior of materials and the problems of degradation and failure follows. And finally, in view of the current importance of sustainability, the environmental impact is stressed, and an outline of the book's contents brings the chapter to a close. So, the industrial use of materials. The science and use of materials is central to all branches of industry, and as such is a subject of enormous importance. The range of materials we have at our disposal is enormous and is being added to as the results of research and development are put to use week by week and month by month. The industries using materials include construction, aerospace, automobile, white goods, electronics, shipbuildings, railways, etc. Each industry has its own practical concerns about materials. In the aircraft business, the overriding concern is with lightness and weight saving, with cost being secondary to this. In the aircraft business, the paramount concern is with lightness and weight saving, with cost being secondary. The automobile industry sector is turning to use of aluminium alloys for body structures in place of the traditional steel. In the construction industry, the goal is most often low cost. So, weight saving is not usually an issue, whereas keeping costs down to a minimum is very important. Finally, we must remember that whatever the industry using and specifying materials, what they are really doing is specifying desirable properties. We shall return to this fact later. It has been estimated that we currently have between 40,000 and 80,000 different materials at our disposal if we count separately all the different alloy steels, all the different polymers, species of timber, type of glass, type of composites, etc. Making the correct selection can be a complex matter. Sometimes none of these have the particular combination of properties we need. In such cases, we may have to make recourse to composite materials. We shall look in more detail at this later in the book. Importance of construction materials. Construction uses a wider range of materials than any other. Materials used include cement and aggregates to make concrete. Metals, primarily steel, but with significant amounts of copper alloys, aluminium alloys, timber, fired clay products, glass, gypsum products, polymers, bituminous materials, etc. The global consumption of the principal material you can see in the table. So, world production of principal materials and the approximate proportion going to the construction industry. Cement include 100% of world production used in construction. Proportion of these materials going to the construction doesn't include fired clay products, which are widely used in construction. Because global figures for this material are difficult to obtain. Such materials are not used in significant amounts by the other industrial sectors. For comparison, the automotive industry consumes just 15% of the world's steel output, a total of just over 200 million tons. Steel is the principal material of the car makers, and the other materials it uses are 40% of the world's rubber and 25% of the world's glass output. So automobile production uses a teeny fraction of the quantities used in construction, and the aerospace business uses less steel. The two major constructors of large passenger aircraft, Boeing and Airbus industry, each deliver between 300 and 500 planes per year, depending upon the economic climate. If the average weight of each plane is 250 tons, this gives a total material consumption of 250,000 tons in a good year. Globally, the annual consumption of materials in the aircraft business is therefore under 1 million tons. However, these materials will be very high value, with our engine materials in particular costing up to 1 million pounds per ton. Another large consumer of material is shipping industry, and steel is the one used in the greatest amounts. The present size of the world merchant fleet stands at 1 billion tons dead weight and comprises just under 43,000 vessels. For the purposes of the statistics, a merchant ship must be our 70-meter long, about 230 feet. This tonnage is being added to at the rate of nearly 100 billion tons per year, with China now being the largest constructor. So, the next table compares the approximate amounts of material consumed annually by construction, shipbuilding, automobile manufacturing, and aircraft production. Finally, all industries use more and more materials as the years go by. The production and consumption grapes are all climbing this time. However, in the developed world, more materials are going into buildings as a proportion of the total than ever before. You can see figure. Here you can see a data for the United States, but the pattern is the same all over the developed world. The graphs shown in figure are very interesting. We can see that consumption of all classes of materials increased during 100 years from 1900 and to 2000. And where was a peak? The peak caused by the world wars and the through this occasioned by the Great Depression of the early 1930 years and the mid 1970 and 1980 oil crises are clearly visible. However, two features are noteworthy. The increase in consumption of materials for construction far outstrips all other classes of material, and economic recession have a disproportionately large effect on the construction industry. And brief history of building materials. The finding and provision of shelter is one of the most basic human needs. When Homo sapiens first appeared on Earth, they existed as hunter-gatherers and would find shelter in caves and other convenient natural features. Around 2000 years, however, mankind began to make the transition from hunter-gatherer to farmer, and men ceased to be nomadic and settled on their farmland. The need to build permanent settlements on their land became a major concern, and this step initiated the development of man as a building constructor. At this time, the population of the Earth would be perhaps 20 billion people in all. Once the human population density reached more than 2 people per square mile, the hunter-gatherer lifestyle was no longer sustainable, and more intensive methods for providing food became imperative. In building his shelter, man would utilize the material that came to hand locally, such as timber, stone, animal skin, and bone, etc. The mastery and use of fire led to the discoveries of ceramic, including fired clay, glass, and also the smelting of metals. As millennium followed millennium, man discovered how to utilize a gradually increasing range of materials. So important were the materials used by man that the ages of mankind's development were named after the material used. Stone Age, Bronze Age, and Iron Age. And so on. And Industrial Revolution beginning at the start of the 18th century initiated an acceleration in the pace of discovery and technological development, so that by the end of the 19th century, man had perhaps 100 or so materials at his disposal to meet all of his needs. The 20th century saw that acceleration becomes an explosion in the number of available materials. So here you can see a history of materials from Paleolitico through Neolitico, added to the metals and other period. This is inferior, medial, superior, copper, bronze, hair, metal. The balance between types of materials has changed dramatically over time. So here you can see a balance of the materials between our time. In early historical times, ceramics and glasses were important together with the use of natural polymers and elastomers. And early composites such as straw-reinforced bricks and paper. So the use of metals was known, but only a few metals had been identified, gold and copper being two of the earliest. By the middle of the 20th century, metals had become the single most important class of materials. So since that time, discoveries in the field of polymer and ceramics have redressed that balances and development of engineering composites have also had a major impact. So this figure illustrates the balance between the various material types over time. It's important to recognize that the figure shows a relative importance of the various materials type and not absolute amount. For example, at the start of the 20th century, the total annual consumption of materials was well under the billion tons. Whereas now it runs at our 60, 70 billion tons. Where the need for shelter is just as important as it ever was. This is true for all peoples in all countries. And the construction industry has grown and developed to meet this need. And as a result, it is the largest industry in the world.